So really quick, we're going to talk about example 2 up here on the board. And when we work example 2, we notice that we're dealing with a problem that's compounding money over a period of time. So here it's compounding over semi-annually. And a lot of times when we have a problem that's compounding interest throughout time, we want to use the formula A equals P, parentheses 1 plus R over N, parentheses N to the T, or NT power, okay? And basically this is still an exponential equation. There's no difference in this than any other exponential equation. We still have our starting point, we still have our rate, and we still have our time. The only difference is when we compound something, we have to make sure we plug in the compound amount as well. So in this problem, we're going to find 4 variables. We're going to find our principal amount, or our starting point, or our starting amount that we put in the bank. We're also going to find the rate at which it increases. So if it increases by percentage, we want to put that in. We're going to tell how many times it's compounded, or how many times they basically give us that amount of money each year. And then we're also going to talk about how many years or how much time is invested in this amount of money. So let's start off with our problem. We said that we have $1,030 in the bank originally. So we know our starting amount is going to be $1,030. We know that our rate of change, or our amount increasing, is going to be 4%. So we know from a previous example, we know that we can write 4% as 0.04 just by simply moving the decimal place 2 places to the left. We also know in this problem that it's compounded semi-annually. So semi-annually means 2 times a year. Annually would mean once a year. Monthly would be 12 times a year. Quarterly would be 4 times a year. So you have several different examples with that as well. All right, so here we're semi-annually, so that's going to be 2 times. And it also tells us that we compound it for 2 years. So 2 years would be the amount of time as well. So to work this out, we're simply going to substitute all of our numbers in for our variables in our equation. So here we know that A is going to be equal to 1,030. We know that we're going to plug in 1. We're going to leave that the same. So 1 plus R in this case is going to be 0.04. And then we also know that our N is going to be 2. And then I'm going to go ahead and simplify it. You can do it however you want to. We would plug in a 2 for N and a 2 for T. But I'm going to go ahead and say that 2 times 2 is 4, just to go ahead and simplify that and eliminate a step when I come over here, okay? So I'm going to write 4 up there. So all I did was 2 times 2. 2 times 2 is 4. Now, to finish this problem up, all we've got to do is basically plug it into a calculator. So if you take out your calculator, we'll start with a 0.04 over 2. So 0.04 divided by 2. That's going to give me an answer of 0.02. So you could write this as 1,030. And then 1 plus 0.02 to the 4th power. From here you can simplify it on down. The rest of it really can be done in a calculator. I would start with my parentheses though, and I would plug in 1 plus 0.02. And you know that that's going to easily come out with 1.02. Then I'm going to raise everything to the 4th power. When I raise it to the 4th power, I'm going to get a long decimal number. Make sure you leave that decimal number in your calculator. And then the last thing I'm going to do is multiply all of this times 1,030. So when I do that, I'm going to find my answer to end up being $1,114. And in this case, it's going to round up to 91 cents. Make sure you put your decimal and dollar sign here. That way you can indicate the amount of money you've grown and your problem's finished. All right. So go ahead and see if you can continue and do the problems on the exam portion of this.